Welcome to another video, this on electrical circuits. This one, we're going to introduce a concept called delta and Y configuration. In earlier videos, we've talked about how resistors can be connected in parallel and how they can be connected in series. There is a case where resistors are connected, but they are neither series nor parallel. Because in order for two resistors to be in parallel, you have to have the same voltage across them. Or if they want to be in series, they have to have the same current across them. In these cases, neither one happens. So here's an example of them on the screen. As you can see, we've got a delta, sometimes drawn this way, called delta. Or it's the same diagram. It's just the lines have been made vertical and horizontal, so it more look like a pi. The resistors are in a pi configuration. So it is interchangeably used depending on which part of the industry you are in and what type of products you work on. It might be referred to as delta or pi. And then the counterpart to that is there's a set of connections that, again, they're neither series nor parallel, but something in the mix of the two, I suppose you could call it that. It's called the Y or T configuration. Now the trick here is that when these things are in circuit and they're connected, you cannot combine them as a series and parallel. You have to do other things to it, and we're going to get to that in a minute. So for now we know when somebody says delta Y, what they're talking about, or pi t, what they're talking about. They're talking about either this configuration or this configuration, which is just the two different configurations. Now, how do we deal with that? So the secret here is that I can take this one, the delta, and convert it to the YT connection. So I can go back and forth between these two configurations pretty easily. All I have to make sure that at this point, the equivalent resistor from A to B is the same as it's down here. As long as I do that, then life is good, and I can go back and forth between the two of them. So if you look at it, RAB here would be basically RC plus these two in series. So RC is going to be in parallel with RA and RB. So, and you can do that for every one of these nodes. So if you go back here, let's go down here and look at the equation. So RAB basically can be either written as the RC in parallel with RA, RB, or you can write it, if you write it for this, that would be the case. If you come here and look at it, RAB is just simply R1 plus R2. So you can see this is one equation, this is the equation, this is three equation, and then we can clean this set of equation up and rewrite them this way. So if I wanted to a delta to Y configuration, I know what RA, RB, and RC are. Doesn't matter whether I have this or this, I know what these resistors are. If I want to convert it to this, all I have to do is figure out what R1, R2, and RC is, so R3 is. And just what you got to make sure you remember, if you're going to use the equation as it's written and you don't want to derive it every time, you just got to remember that A is where RC and RB come together, B is where RCC, so the two branches that come in are anything other than B. Those two branches that come in are any other two that are not C, and all of that. As long as you remember that here, or if you have this configuration, same concept. Then when you come over here, just got to remember R1 is the one connected to A, R2 is connected to B, and R2 is connected to C. If you remember those two pieces, you can simply come down here and use these equations to do the Y to delta configuration and delta to Y configuration. So basically what we're saying is that you can literally take this one and replace it with something that looks like this. And as we talked before about this better call it R1, otherwise you get a wrong answer. You better call this one R2, and you better call this one R3. Okay, and then so obviously you can use these equations down here to make the conversion. Now, between me and you, it's not worth memorizing this information. This is just the equations are just there. Anytime you need it, make a reference to it. Just so you know that we're capable of doing that. So now you wonder, why the world do we do this? What is the benefit of this? So let's go over here and take a look at something like this. So I want you guys to think about this a little bit and take a look at this and tell me how you're going to simplify this. And the answer is I can simplify this because this is not in parallel with this, because you got this thing in the middle. It's not in series because there's an extra branch going out there. So there's no way for me to be able to combine any of these resistors here. But notice what happened. If I convert, if I take this, this is a T or Y, whatever, however you want to refer to it. If I take this T and reconfigure it and call this one, so let's for our notation, we're going to call this one R1, we're going to call this one R2, and we're going to call this one R3, and then we're going to say, okay, if that case, this is going to be A, this is going to be B, this is going to be C. So if I go and replace, let me use a different color, so it's going to get messy anyway, but maybe a little less messy. If I took the B to C and I replace this whole thing with one resistor like this and call this one RA, and then call this one RC, and call this one RB. And notice what I'm doing. The one in front of B, I'm calling RB. The one in front of C, I'm calling RC, or the one in front of RA, I'm calling RA. Now, once I have this, then I can go back to the equations, and now I have the value. Now I can basically get rid of R1, or what I called R1, R2, and R3. I can basically get rid of these ones, and all I'm ending up with is the delta, which kind of sits right here. Okay, now if you look at the delta, now you see that, oh, this is in series. So let me redraw it. It got kind of messy, so let me redraw it. So now you've got the R here, the 13 and the 7. The 13 and the 7 going to stay here. And then all you're going to have here, you're going to have RA here. Then you're going to have RB, and then you're going to have RC. Okay, now you can see RB and let's see, this is RC. So RC and RB in series, they're in parallel with that, and all of a sudden I can simplify this. You see that? So that's really the benefit as far as we are using it in here. The delta and Y conversion, that's the benefit of it here. The delta and Y configuration will come back to us in the future for different forms. But for now, all we are using it is use it to be able to simplify resistive networks. And that's all that is all about. Let me just go down and take a look at, I want to show you some other stuff. So here the goal here was instead of doing what I did, which was turn this T into a delta, they took this delta and turned it into a T, you see, or Y, whatever you want to call it. You see that? Let me use a different color so you can kind of see it on top of each other. So they took the delta and turned it into Y. Once they did that, then they could simplify the circuit because now you got series and parallel situations going. And so most of these problems have lots of different solutions that you can do by figuring out which one you want to convert in which way. And all of them will get you to the same spot. So you can choose to do. And I wanted to kind of show you one other picture here. And I know this picture is a bit messy, but it's worth a few minutes thinking about. So if you notice on this one, and somebody said, how many different solutions can I have? How many different ways can I solve this problem? If you notice, like the green one is basically taking, the green one can be converted to a delta because it's a T. You can take either one of the triangles on either side, which are delta, turn them into Y. Any of those will help you overcome the fact that they're not series or parallel and turn them into a series and parallel so you can simplify your circuit and move on. So that brings us to the end. As far as we're concerned, for what we're doing with this video is we're introducing the delta and Y configuration. And the main purpose we're giving is that in certain circuits, if you were to apply if you convert a delta to a Y or Y to a delta, it might get you to a place where you can simplify your resistive network to a much simpler network. Okay, so that's all this lesson is all. This video is all about. Take care and see you later.